if 80 grams of gas are heated and the change in temperature is 200 degrees, the work expended by this system was 346 joules, and the change of internal energy was 7,000 or so. But we're asked to find what the specific heat of gas is here. So we kind of have to set up two different equations here. We know that the change of the internal energy is equal to Q minus W or plus W, depending on whether it was expended or donated. But this is expended, so this is going to be negative work. So we've lost this much work. And based off of this, we should be able to figure out the Q. So we have the internal energy is positive, 7625 joules equals Q minus 346 joules. And so 7625 plus 346. That gives us Q is equal to 7971. All right. So now we know what the Q is, but let's figure out what Q is. Usually Q is going to be equal to, if we're looking for the specific heat capacity, then that means that we want to have the mass times the specific heat capacity times the delta T. The delta T is 200, the mass is 80 grams. So at this point, we pretty much have our answer. We're trying to figure out what that CS thing is. But if we divide these over here, we are going to end up with grams and then the correct like units for the specific heat capacity. We'll move these over there. So let's try to divide those out. We're going to go 7971 divided by 80 times the 200. And so we end up with essentially 0.498 joules, and then there's going to be the grams and the Celsius there. And this is going to be the specific heat